Data entering and manipulation. These are the learning outcomes of this part. Enter data into the SPSS worksheet, split the file, select cases from the SPSS worksheet, record values into new variables, compute new variables. Uh, Entering data. So we discussed that how we can enter the data. Uh, the data view, the panel of the data editor window is used to enter the data. Here, we can use here to enter the data, right? So this is the data view. Once we created these variables, just we can enter the data as we are doing in Excel. So here you can see the variables. Once you enter the variables to here, then reference number, age, sex, then under that we can enter the data. uh, yeah, the data that you have used in lesson 2 for defining variables, then these data we can enter. We started to enter, then we can finish by when we enter the full data set, we can see that in SPSS like this. So it is one by one, it is mentioned how we can enter the data, right? We did that in last day. Yes. Then here also, then here onwards, we can see how we can analyze the data. So analyze data in subgroups. Then how we can use the split file command. A procedure can produce analysis for the separate subgroups rather than for all the data in the split file option is selected before producing is getting out. The variable or variables that define the subset or are given in the split file command. Suppose when you are doing analysis, so you need to interpret the data in gender wise. It means the number of the analysis for male separately and analysis for female separately. But all the data in the same worksheet without separating those into according to the gender. So therefore, in that case, you can use this split file command. So data is in the same file, that doesn't matter. So, but we can analyze that according to the two subsets. So I will explain you how we can analyze that kind of, how we can split that file, right? So this is the procedure actually. Select data, select split file, select organize, output from the box and click OK, right? So we'll suppose, so without grouping, right? So I am going to take one output, descriptive statistics, descriptives, right? I will take descriptives for mm, what a reference number to here, right? Reference number to here, right? So I am going to take the out. So you can see, yeah, where the out. This is the output. Okay, this is the output, right? So you can see here how descriptive statistics is there. So reference number, there are 10, right? Mean, if an actual reference number we are not taking for the calculation, so we can remove it, right? Analyze descriptive statistics, descriptives, reference number we have to remove. Then okay, right? We can, right? So then you can see here age as large, number of participants 10, minimum is 25, maximum is 55, 58. Then mean, all the things are here for all, right? Here we did not consider male and female. So for each and every person in the sample, this output is produced. But in our case, so we need not like this. I need to separate, right? Males and females. Therefore, as explained in the slides, so we can go, first we can split the file. So you have to remember the procedure, steps, data, First step is data. Then here you can see split file. Data split file. You can see here data, then split file. You can click. Then here you can see this dialog box. Reference so we need to organize output by groups. So therefore we have to click on this one, right? Data is split file, then organize output by groups. So I think if you it is better to write the steps by uh, putting arrows, then it is easy for you, right? Here also it mentioned, doesn't matter, right? So then here we can go here, analyze, organize by groups. Then we need to group using this variable sex of respondent. So we can group based on sex of respondent. Then we can click OK, right? Again, I will explain the steps, right? Again, I will explain the steps, right? We can go, I will cancel this. Then we can go data, split file. Then here, organize group, organize output by groups, sex of respondent. Then we can hit OK, right? Then you can see the output. This is the previous output. So you can see number of participants 10. Now here you can see the in the new output. No, we didn't take the output, just we split file. So then here you can see, here you can see sort cases by sex, split file separate by sex. That is only appear here. Then what you can do here is, then now we can do the same analysis again, right? So analyze descriptive statistics, descriptives, right? Okay. Now what is the difference? So this is the previous one. You can see here number of participants 10, then you can see minimum 25, maximum 58, likewise. But if you are taking after functioning this split file command, now it is split file separated by sex. Now you can see all the data in the same file, but sex of respondent equal to female. Now female is taken as separately. Why is that? We given the command split file according to the gender, right? So then here now you can see that number of participants now 5, because there are 5 female and 5 male. So here also 5. Then minimum maximum here, minimum is 25, maximum is 55. So if you are taking only the female, minimum is 25, maximum is equals to 43. If you are taking male, uh, minimum is 29, maximum is 58. Likewise, in the same file, so we can analyze the data using groups. So for that, we can use the split file command. So once you finish that analyzing part, so you need to off this split file command. Otherwise, all the outputs are given according to this separation. Therefore, we have to off this command. So what you need to do is again same steps, right? Data, right? Same procedure. You can go data, then split file. Now we have to click on this one. Analyze all places. Do not create groups. Then okay. Now we can see here. It mentioned that split file off. Split file off. Then when we take the output, again we can take it as previous one. So therefore then I will show you again the same output. I can take analyze descriptive statistics, descriptives, then okay, again the output is given for all participants. Now it is not separated to the groups, right? That is how we can use this split file command. Right, here mentioned how you can use this split file one by one. So we did this one. Then here how we can turn off this split file option, right? So next one is select cases, another option. A procedure can produce analysis for specific groups rather than all the data in the if the select cases option is selected before procedure is carried out. The variable or variables that define the group retained for analysis or given select cases command. For example, you may want to exclude all the data from people who do not smoke when looking at the summon of the smoking question. So this is different than split file command. So some of the cases we do not need some data. It means data from some participants. So we need to remove those things. If you deleted this data, we can delete actually. If we deleted that data, so we can't take it for the another analysis. Then you have to re-enter the data. So therefore, without deleting, there is an option so called select cases. So then temporarily we can disable those some don't want so the data we don't want for some analysis. So we can temporarily not deleting, temporarily excluding these things for the analysis. So then here I explain so how we can exclude this data for some analysis. So therefore this is the process. So I will explain so how we can do this. Select data, the same tab in split that is split file. See, split file option is also in this data tab. Then we can go for data, select cases, then click on if condition is satisfied. This one. Then you have to go if. Choose filter out the unselected cases. So and choosing an option delete unselected cases. So then choosing the option. So there is a option here. Delete unselected cases means so we delete the other things if we are not selected. So here we are not recommend to use this one. Why is that? Because that is deleted the entire data. So by remaining only the select data, right? Therefore, no, do not use this option, right? Then here, what we are going to do is, for example, exclude all the data from do not smoke. It means smoker equals, we can go for the data set. Here, variable, smoker. Do you smoke? So here it's given if one is yes. Therefore, we have to select only the person who marked one. The others are not smoking. So we need to select only the people who are smoking for our analysis. Therefore, we have to use this option. What we can do is smoker equals to one. We can select, right. Now here we can go. Then from here, do you smoke? We can take here the smoker equals to one. Then we can continue, right? So I will show you. Then this is the data set. So we can go data, select cases, right? Data, select cases. Then we can see here. So we need, I want to click on this one. What? If condition is satisfied. If condition is satisfied, then we can click on if. Click on if. So what we need the smoking people only. Then what you have to select here is, do you smoke? Then we'll check. So if that person is smoke, they recorded one, otherwise zero. Therefore, smoker equals to one, right? Smoker equals to one. So we have to select that one. I think you can get why I take that smoke equals to one, because in this example, so I am going to select only the person who smoked, right? Then we can continue. Then this is the thing that I explained. So then here filter out the unselected cases. So this is recommend actually. So if I select this one, delete unselected cases means delete the others one. It means it remains only the people who are smoking. The not smoking people are deleted if we select this option. Therefore, this one is the best option. Filter out the unselected cases. Then click OK. So we'll see what happens when click OK here. So then we can go for here. So then now you can see there the all the data is here, but you can see then here it is cut. You can see why. So if you go to the smoker, this one two 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 two, it means we are taking now only these smoking people for our analysis, right? So we can see again, I can take the same descriptive analysis, descriptive. So altogether there are 10 participants. Here we see descriptives we can take. Here it's take only 6 participants. Why is that? The other one, the other participants are removed. The reason is because they are not smoking, because we selected only the persons who smoke for our analysis, right? So we can this click turn off actually. So by following the same process, data, select cases, then all cases, all cases, then okay, then we'll see what happens. Then here we can see filter is off, then analyze descriptive statistics, descriptives, we can see now again it is displayed all the 10 data, right? I think you can understand what is the how we can use this split file command and select cases command. Then what is the purpose of using these commands? Because we can do the analysis, we can select actually without deleting the data. We can select what we want for our analysis using these two commands, right? This is how we can. Then modifying variables, recording values into new variables. Sometimes we have to record the values to the new variables. Sometimes you might want to use data in the different forms, such as looking at the age groups, young and old. So here again, then what we are going to do is we are going to separate the age groups according to this example given in the slides. Age 30 and under. So we are going to name those people as young. 31 and above above, we are going to name as old. This is our example. Right, we'll see how we can do now. We are going to separate two groups. One is young people, the other one is old people. Young people are ages less than or under 30 and under. Then if the persons who are more than 31 years, so we are taking as old. We'll see how we can do that. For instance, the values age could be recorded 1, 2, representing, say, young is 1, old is 2, right? Okay. So then we have to put 1 and 2, right? Then here you can create new variables to hold the new recorded values and preserve the original values. So we have to select transform. Transform, that is a new menu. From the transform menu, record into different variables, right? So we'll go for that step. uh, we have to go for transform now. Here you can see transform. Transform, then we record into different variables, not the same variable. So we have to select record into different variables, right? So we can, I will show you again, right? Uh, Data, then not data, transform, record into different variables, record into different variables, right? Then we can go, then we can see the record into record to record age into the age category, age cat, right? So this then we are going to select for new variable called age category. Before that, we have to take click the age at the last birthday, so variable list. So this is the age at last birthday, this is age at last birthday. So we have to insert this into input variable, so I can input here, right? Then that is what we have to do. So we can import this for the numerical value. Then, right. Then next step is click age, okay. Then give an output variable name as age cat. So this one is age cat and its label is age category. So we can change it right here. This is age cat. New variable is output variable is age cat. Age. In simple, it's age and label is age category. Right. Then we can click here change. Now age is recorded into age category. Right. Then once you have decided the variables to record, you need to specify the old and new values. Select the old and new value box. Right. We have to select old and new values. It is here. Old and new value box. Yeah, we can select. Right. Old and new value box. Then what you need to create young to be one. It's called one because we decided to take one for young here. Young one, old two, right? So then we have to create young and old category to be called two, right? Record the values in 0 to 30 into new value one. It means if the age is 0 to 30, that person is recorded as young. Young means one, right? So then here we have take range lowest true value. Lowest true value. That is 30. Right, less than 30 now. Right. So then we can go lowest true is 30. Right. Then it should be recorded to 1. Then lowest true is here. The value is 1 because that is if that is the person's age is less than 30, that person is considered as young. So then we can add here. Okay, then lowest true value is 1. Now it's okay. Then if it is greater than for 31, so what we need to do is, so we have to add it as old. So what we can do is repeat the same process. Then we have to select range value through highest, this one. Range value through highest, so we have to select here 31. Then we have to record this to 2. Then if it is greater than 31, then we can add here. So then we can take this as 2. Is it clear? Any questions? Right? So if it is less than 30, so we can record into 1. If it is greater than or equals 30, we can record it as 2 because that is what we are going to do here. Then we can click continue return record into variables, click out profound options. Right? Then continue, then okay. Now look at here. Uh, here another variable is going to be added here. Then here we can see only filter, right? Then after that, after click on this, you can see another variable is added, that is age category. Age category. So one is for 27, that is less than 30. So it is taken as young. 41 greater than 31, it is taken as too old. But we didn't define this one because this is automatically taken value now. So therefore we have to go for the variable view. Then age cat is created there. So I am there is no decimal points needed there. Then the thing is, so we have to in here we have to define the values 1 and 2. So then here we can click on the values. Then we can put 1 is for young. We recorded 1 is for young. Then add. Then 2 is for old. Add. Then okay. Now it's completed. So then here you can see 1 and 2. How many olds and how many youngs are there? I think you can understand it.
So, excuse me, sir. Say if we want to have another variable to same age category, like maybe between 15 to 25, and maybe
Yeah.
25 to 35, and
Yes.
35 above, like, can we add that, sir?
Yes. Very good. A good question. Right. So I am giving you a tutorial for this time. So only here that kind of problem is there, right? I will explain in using this one. Then here also you can see I given you then low is below 80, medium is 80 to 90, high is above 90. There are three categories here, right? So we'll see another category we are trying to take in here. Right. We'll go for the same process again. Um, Transform record into different variables. So old and new values. So here you can see a range. I will take 31 or above. We took there. So in here range. So just I will write How I can write this? This is not just I'm showing you 50 to 60, right? 50 to 60. So we can keep it as 30. Then we can add to here, right? So likewise, any range we can add here, right? So this is lowest true value, this is highest true value. In between that, we can add any number of data. So we have to use range, minimum value and the maximum value, right? Is it clear?
Thank you, sir. It's
Right,
clear.
okay, okay, right, okay. Now it's okay. So here it's mentioned. Right. So then we can, the next thing is we can compute new variables, right? We can compute new variables. Compute commands are also called because they are assigned values to variables. They may be used, for example, when data not in the form required. Sometimes, I think you have understanding about a little bit of the statistics because, so when uh, before analyzing. So most of the times we are using. There are two types of tests now: parametric tests and non-parametric tests. Parametric tests are the test we can perform for the data in the normal distribution. Right? I think you have the idea about the normal distribution. If not, so you can search and find what is normal distribution. So if the data are spread in a normal distribution, so we can use parametric test. If not, we can't use parametric test. So then we can go for the non-parametric analysis. But the thing is that non-parametric tests are not powerful like parametric test. So in that case, so if we have any not normally distributed data, so our first attempt is uh, anyhow we have to take into the normal curve. So in our national level examinations also they are doing some differences to take all the people into the normal curve. Otherwise that exam is so if you are considering about the exam, right, that exam is not in a quality level. So I think you remember that sometimes they are reducing the marks, especially for mathematics. Why is that? Otherwise, the data is not in the normal curve. Therefore, the passing mark is they are reducing. Likewise, so sometimes if our data set is not distributed in the normal curve, before going to the non-parametric analysis, we are trying to convert that into a normal distribution. For that, sometimes we have to compute new variables. So like this. So we can take the logarithm, so we can take the reciprocal, right? Likewise, we are trying. So after converting some things, so we can have a normal distribution. So we can have the normal distribution. So we are trying those things, right? Um, so therefore, we'll see how we can uh, we'll see how we can this change this data. It means by computing new variables, right? For example, log gauge may be required for analysis rather than actual age. That instance that I have explained, because if the data is not in the normal distribution, we are trying to convert that data into the normal distribution by doing some conversions. So the one thing is this one, the logarithms. Right. So to create the new variable, firstly choose a name for the variable. Now we are going to change age to the logarithm of age. That is the new variable called log age. To calculate the log of age, so this is a process. Select transform, select compute variables. Right, not recording to new variables, compute variables. We are going to compute a new variable. Type log age in the target value box, right? So we'll do that, those things, right? So then now we are going to compute new variables. Therefore, we can go transform, first one, compute variables, transform, compute variables. Then our target variable is log age. So we can type here log age. This is our target variable, log age. Okay, right. Then here, then I have to take log of age. So you can see there is a function group. So you have the idea about the functions. I think most of you are using Excel, right? For some extent. Therefore, you have the idea about the functions. Like Excel, there are several functions here, right? So we want to take this. We have to change this age. This is the age to the logarithms. So then we'll check arithmetic. Here we can say ln and log 10 is here, right? So then arithmetic in the function group. So we can take ln. This is log base e or log base 10 is also there. So I will select this one ln, right? Once we double click on it, it goes to here, numerical expression, right? So I will erase this. So what I have to do is, so here we have to select arithmetic. Then we can go here, you can see ln, we can double click, then it's go to here, numerical expression. So then what we need here is logarithm of what? Age. Age is here. Logarithm, then here you can see the question mark with highlighted one. So therefore we can go for age and we can click on this level. Now what happens is log age is equal to ln age. We wrote a function now, right? Then, right? Then we have to click OK. That's all, right? We have to click OK. Now we can see the last column here. Last column. It is last one is age category. Now here another variable is going to be created that is we called as log gauge. Okay. You can see here log gauge. Then that is new variable. That is logarithm of the age values, right? Logarithm of this age value. That is how we can compute new uh, variables. Right? Any questions?
Can you explain it once again, sir? You don't mind?
Yeah, okay. Right. So I think the purpose is clear, right? Purpose is clear. So then what we can do is again that in the presentation there every steps is there, right? Okay, so you can do it later in yourself, right? Then it's explained each and every step how we can do this, right? So then again, I will take another one here, and another example. Age is only the thing we can take to change, ne? Right? Same thing I will explain, right? I am going to erase this variable now. Clear. Now that is the created one. So what I have to do is I want to find the logarithm of age, right? Therefore, we can have to go for transform, compute variables, then we'll delete all. Then we have to type on this target variable. So then that target variable is the variable we are going to create in here after this age category. So we are going to create log age. So that thing we have to type here. Then we have to take the logarithms of age. Therefore, we can go for this arithmetic. Then here we can select the function ln, right? Then from here, type and label. So we can select age and click on this arrow. Then it's come to between this parentheses. So then if we click on this ln of age, now log age is equals to ln of age. Then they are finding the logarithms of the age. Then we can click on OK, right? Then we can see that last column is created, that's log age, right? If we cannot understand, don't worry, because uh, just take the idea, because we have a tutorial. So when we are, all of the things are included is that tutorial, right? So here we are uh, we are doing this together. Then how we can compute the variables, then total score, everything is mentioned there, right? Today uh, we are going to do this, right? So take the idea, that's enough actually. Right. So then next one is using the if statement. If statement compute new variables. Right. The if statement can be used to in conjunction with compute command. If you have just used to assign values to variables for a specific group of observations, they may be used, for example, when you are required to combine more variables. So if we need to combine some variables, right? You might want to identify the group of people who are smokers, who are strongly agree with the statement that smoking is dangerous for their health. Right. So, that there is two things now. One is the people should be people who are smokers. They have to be smoked. That is the first requirement. And the second one is, so once they are smoking, so they have to have they know that smoking is dangerous for health. Right. So we have to consider two things now. One is whether they are smoking or not. Then the second thing is after selecting the smokers, first thing is we need to select the smokers. Out of that smokers, we have to select those people that know the smoking is dangerous for their health. So earlier, so we consider only one requirement. Then now there are two requirements. We'll see how we can do. Therefore, we can use actually if statement, and then there are two variables here. So then we can see how we can do it. The SPS editor window contains again the transports command we are going to use, the menu compute option. Then here a new variable we are going to compute, that is danger smoke. Right. So we can go for that step as previously, that is same process, right? Transform compute variables. Now we can erase these things. Now our new variable is danger smoke. Danger smoke. Danger smoke. Okay. We are going to give here those who are smoke and, right? Smoke and think it is dangerous. The value is 1 in danger smoke. Now there are two things. One is uh, those who are smoke. That is one thing. And the other requirements is they are thinking that smoking is dangerous. Right? So that for that persons we are going to put 1. Right? For that persons we are going to put 1. Right. So therefore, danger smoke target, then it's okay. Then we can go. Uh, Danger smoke is okay. Then compute target variables. Okay. Then we here you have to see here that numeric expression 1 is here we can give because that is the thing. So we are going to 1 if satisfied. So because danger smoke is equals to 1, so there are two conditions now. Therefore, we have to use if. So danger smoke equals to 1, right? So we can type on danger smoke equals to 1 if, here you can see if, here you can see if these conditions are satisfied, only we have to keep 1. Then include if case satisfied condition. So what are the conditions? What are the conditions? Choose the low include if, then click do you smoke, right? Do you smoke equal should be 1, right? So therefore we can go here. Do you smoke? Do you smoke? Do you smoke? Do you smoke? Here we have to take smoke, that should be equals to 1. Why? That is the first condition. So we have to select the people who are smoking. The smoking people recorded 1. That is the first condition. And there is a keyword and. Why? There is another condition there, right? Then we have to type and here. The other one is that they want to they have to strongly agree. Then they have to agree that once they are smoking, they have to agree that smoking is so dangerous. So therefore, where is that one? Uh, Smoking cigarettes. Do you think smoking is dangerous? I think this one. Yes. Do you think smoking is dangerous? Right? Dangerous. That should be equals to 4 because strongly agree, right? Strongly agrees we assign to 4, right? Therefore, then one condition is smoker equals to 1. It means do you smoke? We keep one, we put one, that who are smokers. The second thing is then we have to use this and the second condition is danger. That should be equals to 4. 4 is that strongly agree on this questionnaire. So you have to remember the last time. So when we are entering, so we put 1, 2, 3, 4 for what? 1 is for strongly disagree, 4 is for strongly agree. So that thing we put here because that's why we put 4 there, right? Then that's okay. Then we can continue, right? Now, if that conditions, then here you can see the conditions. Here, if smoker equals to 1 and danger equals to 4, they recorded danger smoke equals to 1, right? They recorded danger smoke equals to 1 only if these conditions are satisfied. Otherwise, they not keep, they do not put 1 there, right? Okay, now, yeah, that steps are in here. Okay, yeah. Then we can, uh, okay, right. Then we'll see the output. Here you can see danger smoke. I will go here, then no need of decimal points there. Then you can see here 1, but only 1 is recorded. Why is that? We'll see that one rule. Then here 1 recorded, right? This one, it's recorded 1. Then danger smoke. Smoke equals to 1. It means that person is smoking. Then danger smoke. Danger. Uh, danger is equals to for me. That is strongly agreed. So that's that two conditions are satisfied. Then here that then if you consider next one, smoke equals 1, it means is that person is smoking. But when it's come to here, that is also 4. Then it should be also selected. Yeah, danger equals to 4 and smoke equals to 1. Right? If that two conditions are satisfied, second one, after that one, so you can say smoke equals to 1, but danger equals to 2. They are not agreeing with that. Therefore, it is not put 1 there, right? Likewise, so only these two conditions are satisfied. Here put 1, but there is no number to here, right? Therefore, we have to take that numbers to here also. Otherwise, it is difficult to do this analysis, right? So now, after then by clicking, do you think smoking is dangerous, right? Okay. This menus, then output is there. This means that all those who are do not have both functions will give the missing value for this new variable. Yes. So you can see missing value because yeah, that both values are not satisfied there, right? So what we can do for that? Then if do you like to give other people to value such as 0? You have to go through this procedure second time. This time choosing 0 for uh, value of the calculating also using smoke equals to 2. The people who are not smoking or danger not equals to 4, right? Oh, then so what you can do here is now we have to go for the same process. Not equals means this symbol we are using for not equal, right? So then we'll see how we can fill this one, these missing values, right? It means danger is not equal to 1. It means danger should be equals to 2, right? Right. So we can go for same process. Transform, compute variables. Danger smoke. Now I am going to put not 1, 2. 2. For what? Again, we have to go if smoker equals now 2. Smoker equals smoker equals to 2. And danger, here you can see equals 4. Then I am going to put this sign here. Then it's become not equals to 4. This one. because not equals this symbol, right? So that is you can see in near to the escape key, in between tab and escape key in your keyboard, you can see this symbol, right? Then not equals to 4. Now we can click on OK. Continue, then OK. Yeah, change existing variable. Yes, you have to accept because then danger smoke is an existing variable now because we defined it earlier, right? So then now we are going to change it again. So then we have to accept this again. Okay. Now we'll see the rest part filled with 2. All right, there is a mistake I done. What is a mistake? Again, I am going to the same procedure. Why is that? So, yeah, before that, I will explain. Then here we are going to not smoking. Now we are selecting and. What happened? Both conditions should be satisfied. So then it is one condition is satisfied only now. So we have to change and keyword and to O now, right? So we can go to data, transform compute variables. So this if this O value should be, sorry, and should be changed to O and should be changed to O, right? Then continue. Okay. Yes, change existing value. Now you can see here 1 and 2 it's filled because if the both conditions are satisfied, 1, if not 2 here, right? So if sometimes it may be quite complex. So what is the thing you have to do is you have the presentation because the presentation is shared with you with these files actually the SPSS files also you shared with you, right? So what you have to do is you have to try it individually, and if you have any problem, so we have another 3 days. So next day you can ask, then I will clarify where you cannot understand, right? So I know that all the things sometimes you cannot understand within this simple time, sorry, within this limited time, and also this is the nature of the online classes actually because we can't see you, right? So if you can't understand something, it is feel free to ask from me, then I will help you, right? Okay, that is about data manipulation and entry. Right now we are going to start data analysis part. Right. This is the fourth lesson, data analysis. Now we know how to uh, define variable, how to enter the data, then how to record that data into the new variable sometimes. Now we are going to analyze the data. In this point onwards, we are selecting the analyzing part. We are talking about the analyzing part. Right. These are the learning outcomes of this part. At the end of the lesson, you will be able to define the terms data analysis, parametric and non-parametric test. I am briefly explaining you. You can read more to understand that parametric and non-parametric test. Hypothesis testing, again, briefly I am mentioning. Degrees of freedom, normality of data, data transformation, right? So data transformation, it means that as I mentioned previously, if data are not normally distributed, so what we can do is we can transform that data. Test of normality of the data and data transformation using SPSS. Yeah. So the other thing is there are some tests to check whether that data is normally distributed or not, right? So therefore, we are talking about these tests as well. If data are normally distributed, only we can conduct these parametric test. If not, so we cannot conduct these parametric test. So before conducting any analysis, the first thing is you have to check the normality of the data. Otherwise, without checking the normality of data, you are conducting parametric test. So your whole results are wrong because the first requirement is not there. the data is not normally distributed, you can't apply these tests. Therefore, the most before conducting any uh, uh, test, the first thing is that so you need to check the normality of the data set. Right. What is the statistical data analysis? That this term refers to a wide range of techniques to describe, explore, understand, prove, and predict. Yeah, so that is the statistical nature of the statistical analysis. So we have to understand the uh, collected data and we have to do some predictions. But otherwise, actually, we are collecting data for some predictions, not only to interpret the data. But based on the sample data set collected from the population using sample strategy. I think you know those things. How what is the sample, then how you are selecting the sample using a sampling technique, and uh, for that sample now we are doing this analysis. Then we can generalize those findings to our population. Right. What is the sample and the population in statistic? Just to give the idea, right? Not to teach that. Population. A population is the group of all items of interest to a statistical practitioner. Frequency is very frequently very large, sometimes infinite. Population in a country. So that is a sometimes it is very large and it is very difficult to access all the people in a country to do a research. And the other thing is useless of approaching all the people in the country because if we are using a sample, very good sample, the results are more close actually. Sample is a subset of the population. So if you are selecting a part of the population, we call that is a sample selected for study in prescribed manner. So, but when we are selecting a sample, there should be a proper process of selecting a sample. Population is very large, but always less than the population. Uh, Sample is actually less than the population. So here there are some colors. So when we are selecting a sample, each and every color included in the sample, it means so a sample should be the representative of the population. Otherwise, your results can be wrong. So if your sample is not selected correctly using a sampling technique, sometimes your predictions can be wrong to the population because of the sampling error. Data. Information we collected about a topic or subject under investigation, we call data. The information collected about the variable may be singular or plural value. So data means that the things we are selecting. So the previously we put one, two, three something, those are data. Types of data. So, just to have the idea, there are four measurement scales actually. We called, actually, firstly, there are two types of data. One is quantitative data, it is numerical data. The other one is qualitative data. So, in here, most of the times, actually, 99% we are using quantitative data for analyze the data in SPSS. Quantitative or numerical data measured or identified on a numerical scale can be analyzed using statistical methods and results can be displayed using tables, charts, histograms, and graphs. So quantitative data, it is in numerical form. So we can represent using graphs, tables, and many more statistical concepts. The thing is that they are numerical data. If they are not numerical data, so we are considering those data as qualitative data. Maybe there are actually there are four measurement scales. So if you need, you can study further. Whole, nominal, ordinal, interval, and ratio scale. So these quantitative data are measured most of the times in interval and ratio measurement scales. Quantitative interval data is ranked, has precise difference between units of measurements, defines values such a way the interval between two groups value is meaningful. Quantitative interval data, right? How I call the quantitative interval data. Uh, there is no relative zero actually. So temperature in Celsius. So that is actually a quantitative um, interval data. So quantitative ratio data. The data process the characteristics of the interval measure except from the meaningful zero. True ratio exists when the same information is collected from two or more subjects. The ratio of data value is meaningful. For example, if we call height, weight, those things, there is absolute zero. It means if the data weight is zero, there is no weight. But the if the temperature is zero, so we can't say there is no temperature because we have the negative temperatures as well. But that is the difference between that ratio and the interval data. So in the interval data, if it is zero, zero has also some value. It is not representing there is no nothing. But in the ratio scale, so if the zero exists, true zero, that is absolute zero. Zero means there is nothing, right? That is the basic difference. Quantitative data involves amounts, measurements, anything of quantity. Example of quantitative data: 643 dots on ceiling, 25 pieces of chocolates, 8 planets in solar system. Those are numbers, counts. So those are quantitative data. And also measurements, lengths, temperature, average flow yesterday, those things in miles per hour. So these are measurements. That is also quantitative data. Qualitative statistical data. There are some qualitative statistical data sometimes. The qualitative statistical data is the data which is expressed in words rather than numbers. These are measurements that cannot be expressed on a numerical scales, but qualitative data we cannot represent through a scale. Examples for qualitative data: hair color, province you born, astral sign, area code, gender, right? So these things, qualitative data. Qualitative data can be further divided into two, right? So qualitative data, nominal qualitative data and ordinal qualitative data. Qualitative nominal data. Data consists of numbers, participants falling into various categories. Right? Nominal data, it means fat thing, male, female. So these we call qualitative nominal data. Qualitative ordinal data means that is ranking purposes. So, for an example, strongly agree, strongly disagree, agree, disagree, those things, there is a classification actually. So, there is a ranking purpose. Those are qualitative ordinal data. Classified data into categories that you can be ranked. Provide information about relative comparison. Has no precise difference between the ranks, may be either numeric or non-numeric. Okay, so that is actually background knowledge of statistics, just to have a simple knowledge. I think that is not enough actually. So if you don't have a sound knowledge of statistics, just read something about statistics before doing this analysis. Otherwise, you cannot understand why we are doing these things, right? Uh, Key steps in statistical data analysis. Start with your research objective. So, before a research, you are writing the research objective. Decide which variable or variables in your data set or questionnaire can be analyzed to answer the research objectives. So the data collection methods, data collection techniques, the data, everything is decided by the research objective. To achieve that research objective, so we are selecting these things. Decide what statistical analysis technique is suitable. That depends on the number of factors. Then next you have decide which statistical analysis you are going to choose. That is according to the nature of these variables, that is different all the times. Whether the analysis involve one variable, we are going for the univariate analysis. If there are two variables, we are go for the bivariate analysis like correlation. If more than two variables, we are going for the multivariate analysis like ANOVA, right? So that is depends on the variables. Parametric versus non-parametric statistics, right? Parametric assumptions. Following the assumption should be made before performing a parametric test. The observation must be independent. The observation must be drawn from normally distributed populations. These population must have the same variances. So if these uh, assumptions are not met, actually we can't perform parametric test. Most commonly used parametric test, t-test, regression, correlation, and over, right? So there are many. So these are actually most commonly used parametric tests. Then non-parametric assumptions. Observations are independent variable and the study has underlying continuity. Examples for non-parametric tests: Wilcoxon sign transit, man-with-EU test, Kruskal-Wallis test, Friedman test. So these tests are actually, we are not talking about this course because that is actually another part. So another 5 days workshop we can do for the non-parametric analysis, right? Anyhow, so one non-parametric uh, test is introduced to you, that is chi-square test. Actually that is enough for most of the small scale researchers actually. So if we have some treatments, so if we have some many groups, when we are doing a medical research or that research related to the agriculture plantations, so in that cases sometimes we have to use some non-parametric test as well. So but here we are not considering much about the non-parametric test. So if we need some knowledge about the non-parametric test, I think it need to be conduct as a separate course actually. So you can request from your coordinators if you need. Right. Then hypothesis testing. So that is important. I think you know how to write a hypothesis according to the objectives in a research. So these hypotheses are we are testing using the test. That the first thing is you need to write the hypothesis. Statisticians follow a formal process to determine whether to reject a null hypothesis based on the sample data. So there are two types of hypothesis. First one is the null hypothesis. We are usually denoted by using H naught, H naught, H subscript naught. So that is the null hypothesis. The other one is the alternative hypothesis. If the null hypothesis is false, so there is another hypothesis we called alternative hypothesis that is representing H1, sometimes from HA, right? This process is called the hypothesis testing, consists of 4 steps. First one is state the null hypothesis. This involves the starting the null and the alternative hypothesis, right? The hypotheses are stated in such a way that they are mutually exclusive. It means I will explain you how to write the null hypothesis and the alternative hypothesis. That is very simple actually. That is the true. The other must be false. If one is true, other must be false. That is we are writing in mutually exclusive way, right? That is the first step. Second one is formulate an analysis plan. So which test I'm going to use this analysis. So that is the second thing. The analysis plan describe how to use the sample data to evaluate the null hypothesis. Third step, analyze the sample data. Find the values of the test, mean, scores, population T score, Z score, described in the data analysis plan. Last step is interpret the results. Apply the decision rule described in the analysis plan. So these are the 4 main steps in statistical analysis. If the values of the test statistics is unlikely based on the null hypothesis, reject the null hypothesis. Right, so I will explain how to reject and accept the null hypothesis based on the p-value. Very simple thing. Setting up the testing hypothesis is an essential part of statistical inference. In order to formulate either because it is believed to be sure or because it is to be used a basis of argument but has not been proved. For example, claiming that new drug is better than the current drug for treatment of the same symptoms. Right. Look at here. This is the instance actually. So this researcher, what he's going to do is claiming that a new drug is better than the current drug for a treatment of the same symptoms. Right. So then the null hypothesis and the alternative hypothesis should be there. Right. Null hypothesis means the new drug is there is no difference actually between the new drug and the uh, current drug. So that is how we can write. So then this null hypothesis is denoted by H naught. Alternative hypothesis is denoted by H1 or HA. Right. So then how we can write the null hypothesis? There is no difference between two drugs on average. There is no difference between two drugs. That is a null hypothesis. right? Suppose another instance. So there is actually a teacher is conducting a research, actually an experimental research. There are two groups. One is experimental group, the other one is control group. Right? The teacher wants to check uh, if there are any difference between this experimental group and control group. So how we can write the null hypothesis based on this method? Here there is no difference between two drugs on average. So in here we can write, in this instance we can write, there is no significance difference between the mean marks of experimental group and the control group. So that is the first step. So first you have to write the null hypothesis. That is the starting point of hypothesis testing. Before conducting any test, you have to write the null hypothesis and the alternative hypothesis. Here the null hypothesis is there is no difference between two drugs on average. We give special consideration to the null hypothesis due to the fact that the null hypothesis related to the statement being tested, whereas the alternative hypothesis relates to the statement to be accepted if when the null is rejected. So then here, if null is rejected, the other one should be accepted. Then here in null hypothesis, how we wrote, there is no difference between the two drugs on average. Then what should be the alternative hypothesis? There is, so we have to remove no, right? Because that should be the complement of this one. Then we can write alternative hypothesis. There is a difference between the two drugs on average. There is a difference between two drugs on average. Likewise, we can write uh, the alternative hypothesis, right? And the next one is final conclusion is, so we have to accept or reject null hypothesis. Rejected null hypothesis when suggests that alternative hypothesis may be true, right? Because by considering the decision rule, I will explain later. So we are considering with the significance value actually. So a p-value, we can take the p-value from this SPSS analysis. Then we are comparing that p-value with the significance level. Then we can think about that whether to accept or reject null hypothesis. Then, if null hypothesis is false, we have to accept the alternative hypothesis. The alternative hypothesis H1 is a statement of what a statistical hypothesis test is set up to be established. It is the hypothesis that some observations are influenced by some non-random cause. For example, in a clinical trial of a new drug, the alternative hypothesis might be the new drug has different effect on average compared to the current drug. So it means how we can write the null hypothesis we wrote, there is no difference between the two drugs on average. There is a difference between two drugs on average. That is the alternative hypothesis. Correct. There is two drugs have different effect. Or the way I told you, the new drug is better than like some. Anyhow, you can write the meaning should be same, right? Okay. Then we can go, for example, yes, another term is called degrees of freedom. So you can read about that. Okay. Then decision rules, right? Decision. So how we can decide whether to accept or reject null hypothesis, right? That is the important thing. The analysis can include decision rules for rejecting null hypothesis. In practice, statisticians describe these decision rules in two ways. One is the p-value with reference to a region of acceptance. P-value. We are considering the p-value because p-value is given by the SPSS. So it is very easy for us. So based on the p-value, so we can consider whether to accept or reject null hypothesis. Hypothesis p-value. P-value shows the probability your sample test statistics support null hypothesis as true. Right? The smaller p-value is less support. The smaller p-value less support to the null hypothesis, and so higher p-value is support for the alternative hypothesis. For example, p-value 0.55 indicates that support is null hypothesis so that cannot reject the null hypothesis. P-value at 0.01 integrate low probability of null hypothesis to rejecting the null hypothesis. Right, look at here, right? So normally, normally we are taking the significance value as 0.05. 0.05. If our p-value, so that SPSS given the p-value, once we enter the data and just we had to perform the analysis. The p-value is produced by the SPSS. So that p-value, suppose that is this value 0.55, 0.55 is greater than 0.05. If it is greater than, we cannot reject the null hypothesis. The uh, decision rule is it should be less than 0.05. If it is less than 0.05, we can reject the null hypothesis, right? Through the examples, I will explain you just to know. This is actually theoretical part. Practically, I am explaining. The practical approach is to calculate p-value and compare is the level of significance we call that is alpha. That alpha value we normally we are taking as 0.05. If the p-value is smaller than alpha, p-value is less than alpha, right? P-value is the calculated p-value is less than 0.05, less than alpha, we have to reject the null hypothesis. We can reject the null hypothesis. For example, p-value is 0.001, that is less than 0.05. It means we can reject the null hypothesis, right? Okay. Then checking normality. Checking normality. Checking for normality and normalizing transformations. Parametric statistical test methods are valid only when the sample has come from the population distribution that is at least approximately normal. If we are drawing the sample from normally distributed data only, we can do this parametric test. So what is normal distribution? Actually, that is bell-shaped curve. I think you have the idea. The data should be from this sample actually. If the normal distribution is pattern of the distribution of set of data flows, the bell-shaped curve. The distribution is sometimes called the Gaussian distribution in honor to the Carl Friedrich Gauss, a famous mathematician. A bell-shaped curve has several properties. The curve concentrated in the center and decreases at the ends. So then this is the maximum value, then this decreases for these two ends. It means the people who are in the middle are more than the other two ends, less end than the high end. This means the data has less tendency to produce unusually extreme values compared to the other distributions. The bell-shaped curve is symmetric. Yes, you can see a symmetry of this bell-shaped curve. This tells us that your probability deviations from the mean are comparable in either direction. Many statistical tests can assume that the data allows a normal distribution. So we are assuming that, but in our research we can't assume. So we have to show whether this is normally distributed or not. For that, there are some tests. That is very easy. All of the following statistics or methods assume that data is normally distributed. Right. If no data is normally distributed, right? So we can use t-test, f-test, variance, ANOVA, least square, those things. Before applying the statistical methods that assume the normality, it is necessary to perform a normality test on the data. To check whether that data is normally distributed or not, we have to perform this. Uh, we have to perform this normality, this normality check actually, normality test. We hypothesize that our data follows a normal distribution and only reject this hypothesis if we have strong evidence to the contrary. Right. Right. We can use this normal probability plotting may be used to objectively assess whether data from the normal distribution. So we can use this normal probability plot, PP plot and QQ plot to check whether this is normal distributed or not. That is one way actually, but other than that, there are many ways actually. We can take numerical. Right. So this is how we can take this descriptive statistics, descriptives, Then checking the normality of the distribution with SPSS. Now, that is the important thing. How we can check the normality of a distributor using SPSS. There are several ways in which you can use SPS to assess the normality of distribution. Assessing normality by producing a histogram. So you can draw a histogram and check whether that is normally distributed or not. Assessing the normality of distribution using PP or QQ plot. So we can draw this PP and QQ plot. Those two methods are actually quite difficult. There is another simple method to check whether that is normally distributed or not, just to perform Kolmogorov-Smirnov test or Shapiro-Wilk test. Then it's given single value. So based on that value, we can decide whether that is normally distributed or not, rather than these two methods. Because this is actually visual representation. Sometimes we feel that, so this is just like a bell shape, but it cannot sometimes. It may be not sometimes, but if we use the values, so we can easily understand. Third method is use Kolmogorov-Smirnov test. Kolmogorov-Smirnov test is sample greater than 50. If there are more than 50 participants in our research, so we can go for Kolmogorov-Smirnov test to check the normality. If our sample is less than 50, we have to use Shapiro-Wilk test for the to check the normality of the data. What you need to check on the table is significance value. The convention is that significance value is greater than 0.05 indicates the normality of the distribution. 0.05. So if after we are performing this Kolmogorov-Smirnov or Shapiro-Wilk test, if we got a value greater than 0.05, so it means our data set is normally distributed. Right, we'll perform one thing in here. You can see, we'll see, we have five. Right. Right, then there is an example, right? We'll check normality and those things in our worksheet. Actually, I am giving you a worksheet, so we can do it together. So then here, that is the output. So then here you can see histogram. So we can take this histogram. Just we can say that is normal distribution using this Kolmogorov statistics. This is sample size. We'll check what is the sample size. N is equals to 10. 10 means less than 50. 50. We have to go for the Shapiro-Wilk test. In the Shapiro-Wilk test, we'll see the significance value. This is the significance value. What is the value? 0.318. 0.318 means that is greater than 0.05. 318 greater than 0.05. It means that is normally distributed. If that is not normally distributed, so we have to go for that transformation, right? A square root transformation, log transformation, right? Data transformation is important for tool for the proper statistical analysis of biological data. The number of an infinite number of transformations you could use, it is better to use the transformation that commonly used your field, such as, right? So if data are not normally distributed, so we can transform the data and check whether that is normally distributed or not. So most common transformations are log transformation, um, square root transformation, and it is also important that reciprocal, right? Those things are some transformations. It is important you to decide which transformation is to use before you do the statistical test. If you have large number of observations, compare the effects of different transformations on normality of these variables. If you have small number of observations, you may not be able to see much effect of transformation on normality. So if the number of data is very less, so then it is actually you can't see that is normally distributed. Normally, so to be normal distributed, at least there should be more than 30 participants of a research. Otherwise, the results are not reliable actually, if it is a quantitative research. Right. In the case you decide to transformation based on the convention, we can transform log transformation. Right. We did log transformation today. Right. By using the same process, we can transform to log. The other transformation, you should specifically which you are using when you're writing the results. Log transformations are particularly appropriate if the variance increases with the mean. And also the second one is square root transformation. We can take the square root. That log transformation is like this. That we can take uh, age, log of age, transform, compute variables. Here we can write log age as we did earlier. Log age, then uh, what is it? Log. So we can take here arithmetic function, ln, then we can take age, log age. Then okay. Then it's created logarithms of age, new variable. This is this is log age. Simple thing. We can transform, right? The next one is a square root transformation. This consists of the square root of each observation. The back transformation is square of the number. If you have negative numbers, you make square root, right? That's square root transformation, right? So we can go again, square root transformation, transform, compute variables. Now I need square root. Then square root of h. We'll see arithmetic function square root here with sqrt. Sqrt is square root of h. Then okay. So then this is the next one. Then this is square root transformation. Then this is square root transformation. Right? Then reciprocal, 1 over x. Then we'll see how we can perform reciprocal transformation. Transform, compute variable, reciprocal. Reciprocal means 1 over x. 1 over h. Therefore, 1 divided by h. 1 over h. That is reciprocal transformation. 1 divided by h. Then we can see this reciprocal transformation. Right? Reciprocal. We'll see many. Are there any? Arc sign transformation. Where this consists in taking arc sign of the square root of a number. The numbers in which arc sign format must be ranged, right? Arc sign transformation. We'll see. With arc sign transformation. Transform, compute variable, arc sign. Right? Can go for all. Then arc sign transformation. Arc sign. Right? From here we can find the formula, then just the same method. Okay. Then cube transformation. Cube means we have to multiply it by 3 times. Right? So then cube, cube of h, then cube transformation, right? Cube, arithmetic. Are there any transformation called cube? No, there is no cube transformation. So what we can do? Age multiplied by age multiplied by age, 3 times age. Then we have cubed age. Next one. This is the cube, right? At this very large value because we multiplied 3 times. Right, likewise, we can transform our data. Back transformation. Yeah, so this is actually like how then once you, I think you remember that in for the O levels, you did logarithms. So what we are doing is we are converting to the logarithms, the normal numbers. Then we are doing the calculations. Once we get the answer, again we are back transformed to the normal value. The same thing we have to do here. If you transform, we after we are doing calculation, when we are representing, we have to do the back transformation. Even though you have done a statistical test on a transformed variable such as the log of fish, it is not good idea to report your means, standard errors, transformed units. You should back transform your results, right? So the thing is we have to back transform. Then these are the transformed data, right? I transform these things, right? Okay, data transformation, we discuss these things. Transform, compute variables, log, those things. Right. We'll go for this tutorial. Right. We go for this tutorials. Worksheet. So we have to enter this data first. Just I'm showing you and I'm explaining how to do this. Right. So the next day after you are doing this individually, we can discuss it. Right. Otherwise, it is then when we are going to do this individually you may have some problems, so then we can discuss those things. Otherwise I'm explaining everything, so you maybe feel that is easy, or sometimes it may be complex, but anyhow, so you have to take this hands-on experience, then how you can understand it well. So then here it's given some data, student ID. There are 20 students, ages are given, their gender given, math, science, English scores are given, and also the attendance. Let me see. Calculate the mean, median, mode for age of maths, science, and English. So I will show you. You have to do it individually, okay? Right. So this is, I have the entered, right. I have the entered data set. You can see that this is the entered data set. Okay. You have to define the variables first like this, and you have to enter, right? You have to enter these data, right? So these are the given data only. Student, age, gender, med score. These things you have to do. You have in the variable view. Student ID numeric, age numeric, gender string. All the others are numeric, right? Likewise, so you have to define those variables, and then you can enter the data like this. That is the first thing you have to do. Then after that, it's given calculate mean, median, mode for age, math score, science, English score, and attendance, everything, right? Okay. Then that is included in descriptive statistics, right? Descriptive statistics. So we can go analyze, analyze descriptive statistics, analyze descriptive statistics, then descriptives, options. Yeah, we have to calculate what? Descriptive statistic, descriptives. I will show you again. Analyze descriptive statistics, descriptives. Then what we need to calculate? Mean, median, mode, three only for age, math score, science score, English, and attendance. Right. So we need we need to check variables, age, math score, attendance, everything. So we can keep here, then put shift, press the last one, then all are selected. Then we can take this variable with this side. Why we took these variables for this side? Uh, the reason is that it's mentioned math score, science score, English score, attendance. So math score, age is also there. Age, math score, science score, English score, attendance. Everything I got to the analysis. Then we have to calculate mean, median, mode. So then we can go for the options. Options. Then we have to mean is there, median, mode. Here it is not available actually, median mode. So therefore we can't go from the descriptives. Then I'm canceling it. Then I'm going again analysis, analyze descriptive statistics. Then I am going to the frequencies now because I found that there is we can't see that mean, median, mode in that descriptives. Then I go analysis, descriptive statistics, frequencies. Now we'll see. We have to check this again. Gender we are not taking. We need only age, math score, science score. These things we got for here. Then we go for statistics. Here it's mentioned mean, median, mode. We have to click on here, right? Again, I will show you. Again, I will show you, right? I will show you. Then what we have to do? Uh, Analyze descriptive statistics, frequencies. Then we have to select without gender and student ID here. Then from statistics, we can say mean, median, mode. Then continue, right? We need to calculate that all, I think. Median mode, yes. Then, okay. Then you can see the output. You can see the output. Mean for age is here. Mean for math score, science score, everything displayed in this frequency table. Frequencies table, statistics, mean, median, mode, everything. Right? So very simple. Right? Very simple. I think now you can understand how you can take this mean, median, and mode. Right. Second one. Calculate range, variance, and standard deviation for the same set of variables. Right. Again, same process, I think. From there, you can see analyze descriptive statistics frequencies. Right. This is frequencies. Then we can go for the statistics again. Now they do not need mean, median, not mode. They need range, variance, and the standard deviation. It is here dispersion. Range, variance, and standard deviation. Continue. Okay. Then you can see here range for age is given, range for variance for age, standard deviation for age. For every uh, variable, it is just in few seconds we can take the output. Within few seconds we can take the output. I think you can understand now. After enter the data, very simple things you have to do. Right. Next one. Create frequency table for attendance variables and interpret the results, right? Frequency table for the attendance, like this. Analyze descriptive statistics, frequencies. Analyze descriptive statistics, frequencies. Then we need to create frequency table for attendance only. Then we are selecting only attendance. Then no need anything. We need only frequency table, right? Nothing here. Charts, nothing here. So we need only frequency table. Display frequency tables, okay. So this is a frequency table, right? So, 168, 180, 287, 292, likewise. This is the frequency tables, right? So we can create those frequency tables there. Then the next thing is create histogram for Medsco, bar chart for gender distribution, and scatter plot for showing relationship between the attendance and Medsco. There are three things we have to draw in the data visualization. First thing is histogram for Medsco, bar chart for gender distribution, and scatter plot for relationship between attendance and Medsco. But first we can draw a histogram for Medsco. Then here you can see there are two options actually. So one thing is we can go for analyze descriptive statistics, frequencies. Then Medsco we can select Medsco. Then when you go to the charts here, you can see here histograms. Then we can click OK. It is not displayed. We'll see it again. Descriptive statistics, frequencies, uh, charts, charts. Okay. It's not mentioned there. So then if not, there is an alternative option. So we can go for graphs, legacy dialogues. Then we need histograms, right? I think the alternative option is disk graphs, legacy dialogues. Then here you can see, oh no, now its histogram is produced actually. It took some time, right? I given you two. Its histogram is produced now. Yeah? The process, so okay. It's I given two times that two histograms you can see. One is it takes some time actually. So then analysis, descriptive statistics, frequencies. Then here you can see charts. Here you can see histograms. You can draw the histograms here. Right. So if not, we can go for that alternative option as well. That is graphs, legacy dialogues, histograms. Graphs, legacy dialogues, the histograms. So as columns, I can add Medscope. That's enough. Then uh, variable. No, sorry, variable we can take as Medscope. Then okay. Then this is the histogram. Just you can take the histogram. Same as the previous one. This is the histogram. Okay. Right. Next one is bar chart for gender distribution. Right. So we can go, there are two ways, analysis, descriptive statistics, frequencies, then gender distribution. We can take gender distribution. Then we can go for charts. And here we have to select bar chart. Okay. Then this is bar chart for the gender distribution. For the alternative option, graphs, legacy dialogues. Now we need bar chart. Simple bar chart for what? For what we need, variable is gender. Variable is gender. Right. Then again, same bar, same graph. Right. For gender. Right. There are two ways. And the next question is we need to draw a scatter plot uh, for showing the relationship between attendance and med score. I think in here we can't create scatter plot. Analyze descriptive statistics, frequencies, scatter plot is not available in these chart types. Yeah. So then the only way is to draw the scatter plot is this one. Graphs, legacy dialogues, scatter plot, scatter dot. Then simple scatter. Right? The x-axis is for what? One is attendance, the other one is med score. Then med score is the y-axis. Attendance is from the x-axis. Then we can, then this is the histogram. This is the scatter plot. You can see. Just you can draw the scatter plot. Right. The other things we discussed actually, uh, based on you created insight from Medsco, then split file compute variables. record into new variables, those things mentioned there, right? So we are discussing these things. Before that, you have to do this as homework before the next class, because we after then whenever you did this thing, this is in individually, so you may have some idea and some problems sometimes, right? The thing is that the best thing is we have to do this individually before the next class, right? Any questions from the things we discussed so far? Anything to ask?
So this data set is sent to us for a little practice.
Yeah, yeah,
What we have.
yes, definitely. Definitely. These things you
All right.
send to you
Thank you, sir.
with the presentation, right? Then you can
All right.
try these things, right? Any more questions? Right. If not, so now this is your responsibility actually. So you have to try this one before the next session. Then it is easy for you for the understanding purpose, because next day we are going to more complex analysis, right? Before going to the more complex analysis, at least you have to have the understanding about these simple things, right? Otherwise, you may feel that is quite complicated, because we are just actually, we are doing this quite fast, because we have only 10 hours. Within this 10 hours, we have to complete all the content, right? Therefore, it is your responsibility to do this individually and find anything to clarify. Okay, with that, then we can finish today's session. So if you have any more questions, you can ask in the next day. So just before that, if you need any assistance, you can send a WhatsApp message to your coordinator. She will uh, convey that message to me, then I can answer that questions. Right. Okay, then good night.
Good night,
Thank
sir.
you,
Thank
sir.
you, sir.
Good night.
Good night.